SemiConductor is a virtual reality synth and note sequencer offering delightful interactions for shaping sound and generating melodies. The title SemiConductor is a reference to the material found in computer chips, as well as semiconductor as in a musical conductor who cedes some control, in this case to the computer. In the synth, with controllers, players can manipulate the amplitude envelope, high and low pass filters over the course of the note, and the sound's wave shape, or timbre, including toggling through preset wave shapes. The frequencies of the note are visualized in the player's environment, surrounding the player with the sound they are crafting. The synth drives the sound for the sequencer. In the sequencer, the player uses a laser pointer style control to toggle notes on and off. The sequencer generates which notes to play based on Conway's Game of Life, a cellular automaton in which the state of each cell is determined by its neighbors in the previous stage. In this way, the player cedes control to the system, creating collaboratively with the computer. Player tests throughout development informed the user interface design. SemiConductor was developed in Unity and will be available on Steam as a closed beta. For the thesis exhibition, SemiConductor will take the form of a gesture interactive installation, featuring a grid of hexagon modules mounted onto a wood panel. It is the note sequencer from the VR experience, realized in a physical installation. Different hand gestures, detected by a leap motion controller, allow the viewer to toggle modules on and off and initiate the simulation. Each module holds a generative snowflake design that corresponds to a note, and LED strips which are controlled via an Arduino. The piece is programmed using Touch Designer. SemiConductor IRL exists to celebrate the return to a physical exhibition space. Having never significantly worked with material before, the fabrication of the piece was a learning process. The hexagon module pieces were modeled in Blender and 3D printed. Molds were made of the 3D prints, which were used to create multiple castings of the piece. The snowflake designs were cut and engraved on acrylic using a laser cutter. The hexagon grid wood panels and pieces for the conductor stand were cut on a CNC router and assembled and finished by hand. SemiConductor explores how user interfaces shape our understanding of the object or idea. Through delightful interactions, I aimed to demystify the process of sound design and create a fun and joyful musical experience for the viewer.